Gentlemen, welcome back to the shop. Today we're going to have some fun from the Kirkland Country Club, the Koskas. Of all things, it's a towel warmer. No, I did not buy it myself. Baby doll. I don't begrudge Baby doll any kind of those, what you call them, impulse purchases, as I conveniently move my Nipros leather-handled Japanese breaker bar out of the frame. Das Chuch's neat. I'm only allowed to have it A-part because it gave up the ghost about a year in. And it being all of 35 doll hairs from the Koskas, I guess she thought it was a suitable sacrifice. Now, seeing as how it's already fucked, let's have a let's have a try at actually fixing it. I have a feeling it's probably a thermal fuse. Or, actually, simplest thing first, let's plug it in. Let's plug it in and see if it works. Yeah, no power at all. Remember me? Time flies like an arrow. Fruit flies like a banana. Little Karl Marx joke there. When the vanguard of the proletariat and other myths. I need a smaller one of those. Must be some clips. You'll notice we're not at the usual workbench. I haven't changed shops. This is just closer to the fire over here, and it's away from the bamboo 3D printer. Not so fucking tough now, are you? Looks like the lunar lander. About as well built. Now we're into the underoos. Excuse the white balance. That Mylar film on the space lander messes with things. Screws everything up. On the moon too. Here's the power circuit board. Back here with the yellow components. Let's see if we can't get the foil out of the picture. And maybe we'll be able to shed some light on her. We got the power board. The hot wire coming in 120 volts AC. The neutral, which is a ground conductor that is not allowed, that is allowed, permitted to conduct current, whereas normally a ground is not allowed to conduct any current except in a fault state. We have a bleed down resistor, F2. The F designation on the board indicates this is a fuse, the off red thing. A couple of capacitors, film capacitors, a relay, a crusty looking EC. EC. What is an EC? Now this thing, EC, super curious looking. Looks like a capacitor home rolled. Yeah. We got a couple of diodes, and on the back side we have the diodes for the rectification so that we can get power to the control board, because of course the control board wouldn't run on 120 volts, it would run on 5 volts, maybe 3.3. So we need to rectify that AC waveform into DC, and we need to lower the voltage. That's what this is for. On skier's right hand side of the slope, bottom side topwise. If you'd focus it, we're getting there. What is it now? 15 years in? No, not quite that many. Maybe 13. Lucky 13 years. We've been coming together in the shop for a poke and a prod and a chuckle and a chortle. I think it's just about time to pray to the algorithm gods and see if they can't undo that shadow ban I got. I've been stuck at 141.44 million subscribers for nigh on 5 years, which happens to coincide with a certain something something. It appears as though they don't want a remotely competent grown man letting you on to how the world works. Maybe that's years ago, Baby Doll hipped me to this. If you're looking for problems, just look for the shit stains. And that's how I came to be a married man. In this side, none of the ICs, the integrated circuits, the monolithic integrated circuits, what are surface mounted components, have any shit stains. No smoke, no nothing. That leads us to believe, and there's no corrosion, so very likely these components are fine. You can see some high voltage isolation slotting on the board. That's where it's routed out from the high voltage, well, 120 volts, to the low voltage, so nothing can zap you in your shower as you reach. So seeing as how that the control board is not getting any power because it's not lighting up, easiest thing first, let's check that fuse. Check our leads. As indicated by the buzzer, the leads are contiguous. Now we'll go from line to neutral, and there should be some power there. Nothing going on. Not power, rather, continuity. So we'll just check the fuse. I suspect the fuse is blown. No, the fuse is not blown. We're going to have to wake Thelma up and fire up the mystery machine. Find some more clues. You can start checking diodes. That diode's working and biased properly. That is, it only allows direct current to flow in one direction. Let's check that diode. Swap the leads. Oh, okay. So we swapped the leads on this diode, and it conducts in both directions, which means that the diode is fried. The question is that a diode? And I don't believe it is. It's something else, maybe a current limiter or some sort of thermistor. It is encapsulated in glass, but there is a couple of band designations there. Unfortunately, on the PCB, there is no reference designator. That is a letter. You can look up all those letters on the PCBs and find out what exactly it is. F for fuse, C for capacitor, R for resistor, U for integrated circuit. There is no designator on this one, and I don't recognize that. Someone who's better in the know would know exactly what that is. I'll have to do a little research. I probed it with an ohm meter, 5.5 ohms either direction, which would lead me to believe that this is a current limiting resistor, and that it's encapsulated in, no, very likely it's a thermistor. That is, it changes resistance to temperature. So as the temperature goes up, the resistance would go up. That's a negative bias or no, positive bias. No, negative bias. Either way, temperature changes, resistance changes, which limits or allows current to flow. You would want this if the board started getting hot. You wouldn't want it to burn down your hacienda. This is a protection mechanism in order to prevent one mode of failure. Okay, next easiest thing, maybe the cord's broken. It doesn't look broken, but you never know. A lot of these wires aren't even copper. They're copper-clad aluminum. Nope, not the cord. I can't find anything wrong with this power board or the connections. Now we'll move along to the control board. Boop. There's the brains of the operation. Much like myself, not much to look at. Couple of little tactile switches. And IC. Huh. No shit stains. No broken wires. No loose connections. I reseated all of these guys off camera and tested it out. Still not working. I also checked this thermistor and this thermal fuse. Aww. All good. So what we have here is a mystery wrapped in an enigma. I don't know why it doesn't work. Maybe it just doesn't want to. There you have it. There's the teardown of a Kirkland Country Club towel warmer. Of all the first world problems to have, this is one of them. Thanks for watching. Keep your dick in a vice.